Hello everyone, welcome to my YouTube channel. And you are on the Kubernetes show, and we are working on Red Hat and Ubuntu or any type of Linux. It is for someone who is getting started, and we are at chapter 9, which talks about the basic networking, Linux basic networking. If you want to find out my course, this is all on YouTube. It is freely available. You can go on this page, github.com/slash the Kubernetes show, and you'll find two repositories. All right, so getting into the basic networking on Linux. Uh, Before I get started, I want to make sure I set the expectation right. This is not the comprehensive list of everything that you can do. What I'm going to cover today is very basics. And this is to get started with Linux networking, right? So with that, I'll start with what is kind of networking in Linux, right? Uh, if you are Windows user, Mac OS user, even use mobile devices, right? Your devices are connected to either Wi-Fi or a wired network uh, where they are exchanging data. You are looking at maybe YouTube, you are looking at Facebook, Instagram, everything is getting handled using network. Similarly, Linux operating system also needs networking. Why? Because it provides the kind of powerhouse to the internet. Right. In the beginning of this course, I mentioned why Linux is important because it runs most of the productivity systems on internet, no matter it being YouTube or maybe Google or any other uh, functionality or features available on internet, right? So Linux needs something similar. It needs networking, and we're going to talk about that networking. I did mention here that networking is essential for services like web hosting and file sharing, remote access. This is exactly what I was talking about when I said Google, maybe YouTube or any other services, right? So what kind of networks are supported on Linux? Well, too many types. to to summarize, I would say physical network, you could have Ethernet, Wi-Fi, you could have virtual interfaces. If you are working on clouds, mostly you'll be dealing with virtual interfaces, bridges. There are different types. I don't want to confuse you too much on this one, but just understand there are two types of interfaces at very high level. One is physical type, another is virtual type. We'll be dealing with virtual type in this video. You can get hands on a physical machine and deal with the physical type. In Windows, it makes very easy. You have a little icon, network icon, where you click and go configure. And Linux, you need to do things from command line, which also means there is a good way to automate it, and that's what corporates look for, right? But if you are in virtual interfaces, that makes life even more easier because it is a piece of software. It's easy to automate, right? So how do we kind of define or look at these interfaces? How do we name them and all that? We can possibly will talk throughout this video. What else is part of networking component in Linux, right? Your IP address, subnets. If you are new to whole kind of operating system phenomenon, these things are uh, running on series of 32-bit addresses, mostly if it is IPv4, IPv6 128-bit. But you need IP address, you need a subnet within that IP address. For now, just understand you need IP address and subnet. Gateway is a device through which your traffic is going out from your local network, right? So IP address assume your home address. Subnet assume your community within a city, right? So maybe that analogy will help you to understand. IP is your home address, subnet is your community within the city. Gateway is a way to get on highway or freeway, right? So a entry point where you get out from your city or from your neighborhood to another neighborhood, right? So that could be the gateway. DNS is basically the way internet works is it knows the IP addresses only. It doesn't know the names. But humans are not good with numbers, right? If I say you go on 8.8.8.8 to search something on Google, you will feel like, why should I do that, right? When I can type google.com. But that's what happens in the background. When you say google.com, your browser is sending a request to your DNS resolver. Okay, so that's what resolver is. Its primary job is to convert names to IP addresses that your computer can understand. We'll talk about this as well a little bit. Then routing is where all the decisions are made. When I say decisions, for example, you want to get out to a restaurant. If we still go back to the analogy of your home, your locality, then your city, right? You want to go and eat at a restaurant. Uh, to reach there, what road you will follow, what route you will follow, that is exactly something similar routing table does within the operating system. So if you want to go to your neighborhood only, there is a restaurant within your community, very easy. That is kind of local routing. But if you are going from your local network, basically your neighborhood to neighboring city, that might require a gateway in between, and you are going through that. Then you might have to go to another country to experience their cuisine, right? That would be so your ISP getting involved and your packet getting routed, right? So similar to you going through immigration check and getting on a plane, right? That was kind of analogy of it. I have given some links here that you can kind of read on. Before I open this, I wanted to show you something. How does kind of traffic looks like? This whole diagram, it came from this website, not my content. Of course, I kind of used it. I wanted to give credit, that's why I have listed it there. But what happens when a packet gets into your Linux machine, right? Somebody sent you a ping, let's say, or somebody sent you an email. What happens on Linux machine? As soon as packet comes, we call it IPv4. There are two types, right? One is IPv4, another is IP version 6. IPv is version. IPv4, IP version 4, IPv6, IP version 6, right? Somebody sent a request, it gets into your physical device, because that through which the physical device only you are receiving data. It could be your wireless interface, because it is doing RxTX, it is sending and receiving the signals. Or you could have a network cable plugged into your computer, and that's what it is doing. As soon as the packet gets in, there is something called pre-routing. This is internal of Linux routing table, if you ask me, right? So before a decision is made whether packet need to be sent out or sent to some other destination, or should it be handled locally, there is something called pre-routing, right? Then before as soon as pre-routing is completed, it figures out packet need to be either local or forwarded. Then routing, it figures out to whom should I send this packet to, right? So if it is local, it goes into input. Basically, if packet is destination for your machine, it goes into your local queue. All this is happening transparent to you. So it gets into input. Then a process is kind of looking at, somebody sent you email, right? Now you need to read that email. You might have Outlook open, for example, right? So the packet comes, pre-routing, routing decision happens, and on your machine you are running this Outlook, and that is what is the local process. You are responding back to that email, or a read receipt is getting sent. That is uh, your operating system sending it out with routing, right? And then it goes to output. Now it decides where should I send? Should I send it locally or should I send it out on internet, right? Similarly, if packet doesn't need to stay within the machine itself, it need to forward somewhere, then it directly from routing it says forward it to this particular gateway, and that's how pre post routing happens and your packet gets out. Similar story with IPv6. And there is one thing that I did not cover in this one, that is ARP, address resolution protocol. Somebody is trying to send you something, some data, right? How does it know that data need to land on your mobile or your laptop? You might have 20 devices in the home. How does it know that data need to come to your device? So that happens with the help of address resolution protocol. It is basically your machine keep all machines keep track of this with the help of ARP, address resolution protocol. This is generally broadcast. When I say broadcast, it is sending out message to everyone and saying, hey, who got this MAC address is a physical address. Every mobile, every laptop, every computer has something called MAC address. It could be virtual, it could be physical, but generally, when we refer in these terms, we talk about a physical MAC address which is burned in your network interface card, right? So a request gets sent on network and it says, hey, who got this IP address, and it gets into the input. Your system is reviewing through the list and says, oh, I know who this one is for, and that's how it responds back. Either it says, I got the address, or it just drops the packet. That is how ARP works. That is how kind of traffic gets sent. This was very simple. Then there is bridge type of networking. There are other type of networking, and on top of that, you must have seen this one. It says network namespace. Linux has something called namespaces. You can have namespace for network, for process, for mount points. This is advanced topic. I have a video in my Kubernetes series. If you want to go know more about namespaces, please follow that. But coming back to the topic, right? So key concepts. One was IP, netmask, broadcaster, etc. So this diagram came from this link, and that link I have open here, and you can basically read through it if you want. It is bit advanced topic for our today's discussion, but I just wanted to give you an idea how does traffic flow through our uh, network or network stack when somebody sends a email, for example, to us, right? Okay, coming back to this key concept, IP net mask broadcast. All this works based on something that was created years back in somewhere in 1970. ARPA or DARPA, they created TCP IP, and everything works based on that. But I will start with this key concepts, right? So, oh yeah, look at here. It says DARPA created in 1970, right? Hopefully you are able to see it properly. Let me zoom it. And okay, so in 1970, DARPA created TCP IP. What happens with the IP? Right? It's a connectionless protocol, and it deals with only network packet routing, right? It is called IP datagram, right? And it has some information about the packet, right? Uh, so in you can see it did a pop up and talks about in networking it's a self-contained independent packet sent over network, right? Can be routed from source to destination without relying on earlier or subsequent transfer. Now, internet protocol in itself was not enough. Why? Because you are sending bunch of data. How do we ensure the recipient has received data? When you send a file or a picture on WhatsApp or something, right? It doesn't send a file, it sends numbers 0101, right? So similar thing, Linux also does the same thing. It also sends 0101s. And with the internet protocol, it is kind of breaking down into smaller pieces, but the actual control comes with the help of transmission control protocol. This is what defines the data stream. When I say data stream, it sequences the packets. It says packet number 1, packet 2, packet 3, packet 10, packet 20, right? So in between, if a packet goes missing, this is what helps to retransmit that packet. Okay, so all that error correction, retransmission, everything is done by transmission control protocol. So altogether, we call them TCP/IP. Again, this today's lesson is not about TCP/IP. I just wanted to give you a very high level of what is TCP and what is IP, right? Why they are important. Next thing is IP address. Every node has, when I say node, every machine, your laptop, mobile, everything has IP address, right? And then there is a net mask. I was talking about your house within a community, local, right? So this is kind of net mask. You are defining the bit, local bit mask, right? This is what it means. Then there is a network address, there is broadcast address, which I was talking about earlier, right? So address resolution protocol and routing information protocol, they use broadcasts to figure out where to send traffic, who is having a particular MAC address, right? All this information is detected using broadcast. Then um, sometimes during interviews people ask, why don't we use broadcast only, right? It is noisy, simple, as simple as that. It is just every machine having a loudspeaker and shouting, right? How would people understand who is saying what? So broadcast is good if you want to send messages to everyone, but there are problems, right? Everyone is receiving it. Maybe even unintended users are receiving it, right? So you have a attacker who is listening to your network. He's also receiving. So broadcast is not a good way of sending data, unencrypted especially, right? But anyway, next is our gateway address. I talked about getting on highway, a pathway to reach from one location to another. Your traffic gets sent through gateway address, right? So that's what gateway is, right? And this value need to be correct, otherwise your packet will not reach the destination network unless you are in same network, right? If you are in same network, like your neighbors in your community where you live, right? Similar story. Then there are name servers we talked about. Those are DNS name servers. Now all these settings combined together help to configure Linux networking, right? So let's get a little forward. So both operating systems, I've been talking about different kind of operating system. One are Ubuntu based, another Red Hat based. So in Ubuntu based systems, there is something called NetPlan. Ubuntu based systems use something called NetPlan, right? And I have given some links. There is a very nice tutorial here that I've given link on. It talks about how to create LXC, basically making your life very easy to kind of learn it and run commands. Here it is creating a VM, and inside that VM, it is once it is started, got a shell, it is running some commands and helping you configure NetPlan and all that. Okay, getting back to our topic. So main configuration files for NetPlan, it looks into etc NetPlan. So if I go back to this directory, you can see there is a file called 50 cloudinit.yaml. Of course, I need to be root. And you can see it sends some MAC address. It says based on the MAC address, uh, configure a DHCP. DHCP is dynamic host configuration protocol. So there is a server which is handing over IP addresses, IP address, netmask, gateway, and possibly your um, time server and your DNS server information. All that comes from a DHCP server. Uh, you can configure all these settings manually too: IP address, netmask, gateway, and your DNS. But generally, when you use things in your home, you are using on mobile or laptop. You don't go and configure 192.168 IP address on your laptop, right? It just magically works. That magic happens with the help of dynamic host configuration protocol, DHCP. Again, how DHCP works? It works based on ARP requests. It is sending ARP requests on network, the broadcast. Your DHCP server gets it, and DHCP server says, "Oh yes, I know this MAC address." If you have configured static, if you have not, your DHCP server might basically say, "Okay, here is a IP address that I'm ready to lease to you." There is a concept of leasing. So your machine gets the IP address and it says, "Okay, I got it." And that's how your lease gets registered. Lease is for limited time, then it gets renewed. Not a topic for today, but that is something you should know what DSCP does, right? So in our case, this machine is getting from DSCP, and there is a configuration file. We call it resolve.conf. So what is resolve.conf? Resolve.conf is used by your DNS resolver. Remember, I was talking about that your system knows only IP addresses. It doesn't understand what is google.com, right? So how do we resolve it? How does Linux know how to reach out to google.com? So you use something called etcresolve.conf in Linux, and in it is controlled using systemd resolved service. So if you do cat by default, as soon as you install the Ubuntu system, you'll see something similar, right? It is running a service which is basically, you can read more about systemd resolved on man pages, right? And this is how you can check the status of it. Resolve d status, and you can see it is giving some IP address, what is the DNS server and domain and all that, right? So this is what resolve.conf does. There is a file called etc hostname. So this file, make sure your host name is getting set for the machine, right? It says, this one, I think similar thing is available on Red Hat, but it is not set because you use host name CTL, right? So something like this, you can use this to kind of set it, and here it is unset, that's why you don't see a value. But anyways, let's see if this one has host name CTL. Yes, it has. And uh, yeah, so static host name, you can see it says learn Linux, right? Okay, all right. So we know NetPlan that configures your IP, NetMask gateway. We know resolve conf that configures your DNS. Host name configures the host name, right? But what if you know IP address of something and you don't want to go to DNS? When I say DNS, there is a service provider running DNS for you, possibly your ISP, right? So you're sending a packet from your laptop to that DNS, then DNS says, "I know the answer," or it sends to kind of a uh, so-called top level domains. It is kind of going by hierarchy, and finally it either gets a answer or says, "I don't know," right? But what if you want to resolve something locally, right? In those cases, you can add an entry in this file, etc host, right? So in etc host file, you can add IP address and name. So this is how in Linux you kind of make this persistent, right? So if we see, it is owned by root. Others can read it, but they can't write it. So you need sudo to modify this file. But the format is IP address and the name, and then you can do fully qualified name and all that, right? Um that is one way of doing it. But even after making an entry in this file, what if your requests are still going on internet? You wanted to kind of contain the request and keep them locally rather than going on internet, right? There is another file called etc nsswitch.conf. So in this one, you see the format. It says what type of file, or what type of search, and what type of entries, where should it look first and where should it look second. So that is how it kind of works, right? Name service switch. That's it came from Sun Microsystem. Sun Microsystem has a lot of good contributions to today's Unix world. So NSS switch, it solves a lot of problems, including password and others. But today we are talking about host. So if you make a entry and this is second in the list, let's say you had DNS and files, no matter you make an entry here, your request is going to your DNS servers. If it gets a response that I couldn't find it, then there is a possibility it will look into files. So if you switch these two, like DNS first, file second, but in this case, your request will stay within your machine. It will look at etc host file first. For example, here also, if I say, you know, files DNS, and then you can specify where should it go, right? But this is primary, secondary, tertiary, all that you can define. There are man pages available. It is, these are very well documented. Since Sun Microsystem no longer here, and these are kind of standard files, you'll find them well documented everywhere on internet. You might find several videos too. But this is the way resolution works. Your machine sends a looks at etcresolve.conf, then sends a request. But before that happens, it looks at NSS switch. If NSS switch says look into files, there is a request that goes into cat etc host file, and if nothing found, then it goes to DNS, right? So that is another thing I wanted to highlight. Again, you can kind of read through these. As I was saying, there is a net plan tutorial. I don't want to cover, I don't want to run commands and kind of bore you with the details, but that is what net plan does. It goes and configure your network interfaces. For example, here it says, you know, status all, like you are running, and it shows your different interfaces, what is their state. LO is loopback, right? And ENSPOS1, this is your interface name. Now this looks pretty scary, intense. You can control the naming scheme. There are ways. I have listed something here at the end. So if you are really interested into it, look into this man page, man system d dot net hyphen naming scheme. So if we, just to show you, you can see how do you define this naming scheme. You can control it using your grub configuration file too. When system boots up, you know, at the boot time, it looks at etc grub.d. There is something, hold on, default grub. Yeah, so here you can define, in this file you can add parameters to control uh, what type of naming scheme should your interfaces use. Okay, so coming back to the topic that I was talking about. Okay, so we talked about net plan and similar story. The thing I was showing here, this default grub, it is available here on Red Hat too, and you will see something here, BIOS dev name 0, right? So it is kind of disabling it. So what is the result? If I say if config, you can see there is a eth0, there is lo. So eth means ethernet 0, right? So here also, if I say if sudo su ipa, I'll have to do, because it doesn't have if config. Yeah, it doesn't have. I can install a package, but Linux in general is moving away from if config command. They are going towards IP. So use that. For example, IPA, right? And you want to see only particular interface, IPA show dev eth0. Now you can see it is showing one entry only versus earlier with the IPA. A is address. A is small form for address. Okay. Then similarly, you have a IP link. It shows you whether your underlying link is up or not. If it says lower up, it means your interface is getting data. Okay, coming back to the topic. So in Red Hat Linux 8 and above, there are there is something called Network Manager. Okay, so Network Manager is used to configure network related configurations. Earlier in Ubuntu we saw it was NetPlan, right? So in Red Hat 8 there are, I've given some links, you can read through it. In older times you could go and create files here in etc sysconfig. When I say older time, maybe Red Hat till Red Hat 7 it was kind of available and people were using it. Now it is kind of getting discouraged. You should not be using these files, right? So if you see ifcfg ets0, it gives you some details here. But then there is another file, if you see readme, and that also talks about you should think about using nmcli, right? And then it says migrate. They are recommending moving away from uh, in etc sysconfig network, right? In network scripts. And there is another file which generally defines your default network and all. It's etc sysconfig network. This one will not have it, but Red Hat used to have. Anyways, coming back to the documentation, right? So you have utilities called nmcli, network manager command line interface, and nmtui. This is kind of ncurses based interface. So let's try nmcli. If I run, it gives me the output. Basically it is, what it is doing is, I think it is doing device show and it is giving me the output, or it might be doing connection show and then, for example, eth0, right? So if I run nmcli, it is giving me the output, right? Okay, nmcli. Then hold on, there are a lot of options, like you can look into networking devices. You can monitor, right? So like channel, and you can see the status, whether it is connected, what type of connectivity is half duplex full, wi-fi enabled, wlan and all. uh, you can not only see, you can even modify, you can do edit. And let's say uh, connection and ets0, connection edit, I think that's what it was. Yeah, so you can see prompt changed and I'm here, and I can now start working on these things. Like I can do like describe property here the way they have shown, right? ip4, and it gives me detail. Then I can use this to set properties. If I want to see all, I can do print, and it is showing me the kind of all the interfaces and details for them. But anyways, that's not the topic. One was nmcli, another is nmtui. Now you can see what it shows, right? Now you can see it says edit, activate, set system host name, and radio, let's say, right? You want to enable, disable, right? This is coming from general that I was showing you earlier, right? And then if you say edit connection, which connection you want to edit, right? Let's say ets0, then you can see interface, and there are details. All I'm doing is pressing and enter if I select something, right? And it shows whether ip4 is automatic, is it manually set. If I say manual, then I'll have to go and save and then configure IP address. For example, here I'll say 192.168, right? I'll have to do this, but I don't want to. It is not what I intend to do with this guy. And let's see, I'm pressing escape to go back, and if I press escape, I'm kind of exiting out of it. So there are ways in Red Hat Linux to configure your network interfaces, right? So let's see, what do we have here? Network connections, and you can see there is a network connection. And if we see the content of it, I'm running all these commands as root, and you can see there are details given, what is the interface name and how to kind of configure it. So you, instead of placing files into etc system, then uh, etc sysconfig network scripts. Now you are placing in etc network manager, right? And how do you see the links that I was showing you, right? We had this ip link show, ifconfig a, that is also there. Then you want to see ip address for everything. That is by default when you do ipa, that is what it does, it is showing you ip address basically, right? Then how does resolve happen on red hat systems? So you could have this file etsystemd resolve.conf, or you will have most certainly this one. I think this one is for ubuntu. Let's see, this is, let me try on ubuntu. Yeah. So in Ubuntu, you can see your systemd is reading this file. Remember, I was showing you systemd resolved, um, the man pages that I was talking about. That is what is looking at this file and accordingly configuring your DNS fallback, DNS domains, right? So this resolve.conf file gets updated with the information that you supply there. Again, that was more for ubuntu, not red hat. But in red hat we see, when I did this, it says network manager generated by network manager, right? How did it happen? Nmcli connection list connection, and show. If we see this, and then we can do grep, then dns. And if you see DNS, it says default. Almost everywhere it says default, and because it is automatically configured, that's why you are seeing this. So IPv4, and if I search for it, right, send host name deprecated, and almost all the settings. For example, this is what is configuring your uh, DNS as well. Not only just IP addresses, but DNS too, right? Okay, how do we see routes? Remember, I was talking about routing information. This is how you see the routes. Anything that says default, it says default via this IP address, and it should go through this interface. And what is the source? So if I say IPA, this is the source IP. Okay, when anything need to go out, it need to go through this source, using this interface, and this is your target where it need to reach. This will be my machine, my mac os, where I'm running all this, right? So this is your kind of scoped uh, from source. Then this is scope link, but anything that need to go through this particular link, it'll go from this ip, right? Then you're sending, so once it reaches this guy, this is what is working as gateway, and it is kind of sending and receiving traffic and sending packets back to my machine. So when I say ping gmail.com, so I'm getting a response because my packet is going through this. So um, we can do trace. I don't know if I have it, trace route. Trace, yeah, let's try trace path for this, right? So you can see it says localhost, then gateway, then it is going through, right? All this response time, this is, or this is packet, maximum transfer unit 1500. All this is coming with the uh, ICMP, mostly, right? All this response. Anyways, you want to read more about this particular thing, resolve.conf. This was what I was saying, man page, systemd resolve, right? So how do you check? Another thing in all this, this was still local on your laptop. What if you are running this in cloud, right? So in cloud environment, generally you use something called cloud init, right? So if you are on Ubuntu, you will run this command, right? And you can see we have something installed. If I run rpm because this is Ubuntu, it won't work here. But if I run here, you can see I don't have cloud init installed on my Red Hat machine. So how do we check? There is something called status, cloud init status. It says done. Since it is not installed, it will say command not found, right? Red Hat says command not found. What does it provide? An example. Here I'm running a command. I'm looking at home directory of user Ubuntu. Inside that home directory, I'm looking at authorized keys, right? So uh, there is a authorized key added with this content in the home directory. How did it come? It came with the help of cloud init. So if I run a query, and you can see this is exactly same thing. At least you can, like, if we want to see a smaller portion of it, right? So that is just one thing. What if you want to do query everything? You can do query hyphen a, and then it prints almost everything, right? So to keep it simple, all I'm trying to show you is when you boot a machine in cloud, your settings, your configurations come from outside, and cloud init is what that helps to configure your VM. Okay, so one of those settings could be your IP address, netmask, gateway, your your NTP server. All those settings uh, would come from cloud init, right? At least cloud init would configure your VM to receive bunch of settings. Yeah. So then if you want to see something specific to network, you can do this, right? You can see it is network, netplan, network manager. All these settings you can send through cloud init. Anyways, um, if let's say you are running on cloud, you want to disable it, there is, you can send this network config disable and send it to this file. I'm doing it with sudo because this file is this file need to be written with root privileges. By default there is no file named 99. Again, this is something you should know. When we run this, for example, if I look into this, there is a file called readme. So if you see, it says lexical order. So anything 5, 6, 7, 8, 9, all those kind of getting read into a sequence. That's why this file name is 99. If you are disabling, you want this to be the final entry, right? Anything in 5 will get merged into 6, will get merged into 7. So all the files are kind of getting merged, and the last one is kind of what gets applied, right? So you, in the end, what cloud init sees is kind of consolidated view of everything, right? I've given some examples of netplan. How do you see, how do you apply? These are some commands that you run. Similarly, on Red Hat, you run commands with nmcli. Again, these are run with root, right? How do you configure a network interface and all? You can do nmcli like I was doing, or you can do nmtui. TUI is okay if you are doing interactively, but what if you need to kind of automate, right? That's where nmcli comes into picture, right? Then showing some commands, how do you trace and how do you see routes? Resolve.conf we already checked, and once changes are done, you restart maybe systemctl resolve or network manager, right? Once changes are done to your configuration files. I've given some homework for you. It ended up being a little longer than what I expected, but I hope it was able to give you an idea. How does a packet get into Linux? It travels either handled within the Linux or gets routed outside. What are the files? For example, etc host, etc hosts, s, right? hosts, etc hosts, etc host, etc host name, nss switch, then etc resolve.conf. Then we looked at netplan, we looked at network manager configuration files. So I know it was pretty loaded session, but if you have any questions, please comment on my video, or you have a recommendation, you would like to contribute to this, uh, feel free to open a pull request or comment on my LinkedIn if you like. Thank you so much. I have given some homework for you to kind of play with it. I have given links, for example, to this NetPlan tutorial, walks you through, guides you how to kind of run NetPlan. Uh, do some hands on, create a VM, play with it, and let me know if you need any help. With that, I'll close. Thank you so much and good luck. See you next time.